Hi everyone, my name is David Capetti and welcome to this Rhino and Grasshopper tutorial. In this video I'll be going over the steps for creating the start of a standalone structure, and this is an A-frame design where we have the width of the structure here. We also have the height. We also can change the length of this building. We can round off the building this way. Also, at the end, we explore other options for the way that we sweep the building around. And we also offset this to create a specific size and thickness to this design. I'll be going over all of those steps. Make sure to ask any questions if you have any. And let's go ahead and jump right in. To start, I'll go here inside of Rhino. And let's go here to Units. And I'll be creating the structure in feet. And then I'll have feet in inches. And I'll have a new Grasshopper file here. Now let's create a plane that is upright in the XZ plane. So I'll actually go ahead and bring in an XZ plane. And typically we could just use this XZ plane, but I actually like to give it an origin point. So I'll go to construct point, and this way we can use that original point at 0, 0, 0 as our origin point, and we can move it around this way. And actually what I like to do in between that is bring in a point component. This way, we can set one point and move that around if we need to. So that's going to be our plane, original plane. Let's take a point, which is going to be this point, and let's move it up a certain amount. That's going to be the location of the height of the structure. So let's go to a move component, and let's plug in our point. And let's move it up using our motion here. So I'll double click, bring in a unit Z, and we could plug in into the motion here. Now let's give it a factor. So I'll just say about 25.00, and this will give me a slider from 0 to 100 with 2 decimal points in the middle. So let's change this to structure height. What I also like to do is group it, and we'll leave the color this way, but you can double click on top of the group and change it, change the style that this kind of groups around. Let's do box outline for now. And as you can see, this is called a relay, and what it does is it allows you to turn on and on information. We don't need that though. Let's use this one. Now let's go ahead and move this point to the right hand side. So let's go ahead and bring in another move component. And this point we will move in the X direction. So we'll bring in the X unit X, and we'll plug in the unit X vector into the motion. Now we can copy this one or create a new slider. So I'll just copy this one over, plug this one in, change this structure width, and I'll group this together also. This way we can move this point in the unit X, and the way that I guide myself is here at the bottom left of your viewport. You'll see a X, Y, Z coordinate system here on the bottom left, and you can see and guide yourself as to which way you're orienting your view. So with that being said, we moved it in the X direction. Now we want to move this one in the X negative direction. Now we can also mirror it. So there's various ways to do it. Let me show you. This one, we can just copy it down and bring in a negative component, allowing us to move it in the opposite direction. right? This gives us 25 on each side from the center. The other way is to bring in a YZ plane, which is going to be a plane that is upright, basically sectioning or cutting through the center of the ridge. And this will be our mirror plane. So when we bring in our mirror component, we can plug in this plane into the input, and for the geometry, we would use this one. So that's another way that you can create that one, but as you can see, it takes a few more steps, and with what we have, we can already create that. For me, the critical portion of this is that when we move this 20 feet to one side, it's actually halfway. Like if I wanted to know the entire width of the structure, it would be it would be twice as much as this. So what I like to do is divide this by 2. This way I have the overall width of the building. So I'll do divide by 2, and this will give me a division with A and as an empty parameter, and B with 2. So we'll do 20 divided by 2, and this will give me 10. But this is more accurate in the sense that now we know the actual structure width, in the sense that when that's 20 and this is 40, it's moving it from the center halfway, so we have the overall width. So with these 3 points, we can connect them. So I'm kind of organizing this here. We can connect them and use a polyline to do so. So we can do polyline. We can plug in all of these points into the vertices. And as you can see, there's always, when you have 3 points, it'll go through the first one, second, third. To make sure you close it off, you right click on the closed portion of the component, and you're going to go to set boolean true. This will make sure that it closes down that polyline. The next thing we're going to do is just offset this down, and you can offset this out or in, it doesn't really matter. But for me, since we have the structure width, the overall width here, I would want to offset it to the inside so we maintain that dimension. So let's go ahead and offset, curve. And one of the things that I've been noticing that's critical is to use a plane. This way it remains consistent. So for this polyline, we'll bring in a boundary surface component, and we'll plug in that polyline into the input there, and we'll use the surface as our reference plane. Then we can use the polyline as our curve, so it'll reference this surface as our plane, and it's offsetting to the outside, so we can either flip the direction of the polyline here, or we could just go to negative component, and we'll use a negative value for the distance. So let's go here to 1.5. So that's 1.5 feet. And if you wanted to use inches value, so this is units feet. So if you want to turn it into inches, you can say, if I want it to be 6 inches, so I'll bring in a 6 slider, I would divide this by 12 to turn it into feet or into inches, and then use that as the distance. So this actually is 6 inches, and this is 1.5 feet. So this is 3 times as much. And we can see here, do 24, which would be the same thing. So we can use this one for feet value and this one for inches value. 24, same thing as 2. for us to here. There you go. Cool. So I'll use that for my inches value, because if I'm going to use like wood, then I would want to know the exact size of the wood that I'm going to use. So for this one, we'll change this to rafter size, and we'll just say 12-inch. We can also bring in more decimal points. Let's go to 2 here. This here, and I'll group this one together. Cool. Actually, put this down here. So I like to try to maintain it organized. Cool, awesome. So let's take this curve and this curve, and let's actually put that together using boundary surfaces. So we'll take this one, we'll hide it, middle click, disable preview, and let's go to boundary surfaces using the polyline, the original polyline, and the offset polyline, making sure we flatten the input and giving us the plane in between those two curves. Cool, so now that we have this surface, let's create a line here, like an L-shaped line, and this will give us the shape that we can use to sweep this form around or extrude along. So there's a few different ways that we can get the shape to sweep around a curve. We'll be exploring one of those options. And so what we'll do is go back to one of these points, and we could use any point, right? We could use this one and create a L shape this way, or we could use the ridge and create an L shape. I would like to use the outside face to create the L shape. And the reason why I use this right side is because we'll be using positive points going up in the Y direction along this green axis, and then we'll be moving towards the positive X direction here along this red axis. So let's take this point and let's move it in the Y direction. So we'll plug in this point. We'll actually plug that into the geometry. The vector is going to be into the motion, and now we can bring in a component for the length of the building. So let's go to 30. So we'll call this length. Building length 1. And we'll move it again. So I'll just copy this component, and the way I do it is just slide it out, hold Alt, and it makes a new one. Now I can plug in this geometry into the input, and we'll change the Y value, and we'll go to, so I'll copy this, call this building length 2, and bring in an X unit X, moving it in the X direction. So now we'll take these 3 points and we'll bring them together. So we'll go to a curve component, or a polyline actually, and we'll plug in all of these points in order. This will make sure that the polyline is created correctly. So let's hide these 2. And now let's move these around and see the various parameters for the length of the building. And so let's go ahead and use extrude along. Extrude. So we'll use extrude along. And for the base, we'll use this surface. For the curve, we'll use this polyline. Now, as you can see, it doesn't actually sweep it around correctly. So this is not going to be the correct one. The correct one's going to be sweep. And we'll do sweep 1. We'll bring in the edges of the surface. We'll go to brep edges. And we can use the outside edges or the naked edges as the sections. And this polyline we can use as the rail. Now, since there's more than one here, since there's 6 of these, it's actually going to be better if we get rid of that and just use the original polylines one at a time. So this is one section, and we'll copy this and we'll do the next section. Now we'll do turn them into a solid. So do a cap, and we'll cap both of these and subtract the outside, which is this one. We'll subtract the inside from the outside portion. So let's hide both of these, and let's go to solid difference. We'll use the outside into breps A and the inside one into breps B. We'll hide all of this stuff. And this is the overall form of that A-frame structure now. As you can see, we can come back and change all of these parameters. And this is going along the lines of the standalone structures that I like to create using parametric design. These are pretty straightforward, but I think these are critical steps to be aware of how to just move things around using simple moves. And from here, you can just increase complexity in the sense that when you start developing this script, you can add patterns, you can curve attractors, a bunch of different things that can add complexity to your design. But it comes down to, in my opinion, to learning the basics. With that being said, now that we have this here, or that is our curve, right? If we take this curve and we just change it, our sweep is also going to change. So this is what I like to do, is come back to the basics of how we created the geometry, and let's go ahead and just create a fillet to round off the edges of this curve. And for the radius, I'll say 1.5. And let's increase that. Let's give it a few more numbers here. So increase that to 20. And we can use this curve as our input for the rails. Now, I could easily just take this one and plug it into those, but I think it would be useful to bring in one curve component, which we can plug into here, and this way we can plug in our sections. Or actually, this is going to be our rail. We'll plug in our rail here. And now we have this ability. Now I noticed that there's no chamfer, right? If you want to take this curve and you want to, instead of it being rounded off, you want it to be to cut across, there is no chamfer in this version. So what I like to do is I can go to a component called discontinuity and increase the level to 2. This will give you the points starting here and where the arc starts and ends. And now I can use a polyline to put those points together with the vertices. And now we can use this as a chamfer rather than a fillet. So and this fillet parameter, or this radius, can be that rounding off. So depending on which one you want to use, you would change this one to this one. And those would be basically the parameters for this video. Now I do want to come back and add more details and show you step by step how I want to detail this one out. Thank you very much for watching the video. If you want to download the script, go ahead and go to capettidavid.com, and there will be a video scripts button for you to click on. There is a $5 fee to sign up, but you will be allowed to download all the scripts from the past, and also all the scripts that I'm going to post in the future. So this is a place where you can find not only videos, but a way to contact me. And I also have other services like tutoring and other courses that I post on other sites. If you enjoy the content, make sure to subscribe to the YouTube for future videos, and I hope to see you next time.